Hi everyone, welcome back. This is Module 1, Section 3 on properties of numbers. So basically, a math property is any rule that is always true. Doesn't matter what the numbers are, it will always be true. Now, you guys have actually learned a lot of properties throughout the years. I'm going to go over a bunch of them today. Some of them, I think most of them you already know. Maybe there might be one or two you haven't seen before, but it's going to be important to review all of them so we can use them as we move on. Now, as I go through each one, I'm going to give you the name of the property, but that's definitely not the most important part. You don't need to worry about memorizing name by name. It's much more important that you remember the concept of what we're talking about. If I tell you a rule and you understand the rule itself, but you forget what it's called, that's not a big deal as long as you know how to use that rule. So let's start with a group of three properties that are all together called the properties of equality. Now, number one, we're going to start with a really obvious one. It's so obvious it barely even needs a name, but it's called the reflexive property, and it basically just says everything's equal to itself. So for example, 5 equals 5. That's true. 3x plus 7 equals 3x plus 7. That's true. Like I said, very obvious. Of course we know that. Of course we know 5 equals 5. It's the same thing. But it is a property, and it is one that we want to know. So if you ever need the name for it, it's called the reflexive property, and it just says that if you have two things that are exactly the same, they're equal. Okay, number two is the symmetric property. And what that says is you can basically take an equation and flip it and it still works. So if you have two things that are equal, it doesn't matter which one is on which side of the equal sign, is basically what that says. So for example, 3 plus 4 equals 7. That's definitely true. We know that. It's an easy math question. 3 plus 4 is 7. But if I flip it around and I say 7 equals 3 plus 4, it's still true. It's just saying, it's symmetric. You can flip them and it still works. So when you have an equation, you're allowed to flip it. Like if you're solving for x, it doesn't matter if you say x equals 5 or 5 equals x, you still solve for x. And then finally, number three, we have the transitive property. And it says if two different things are both equal to the same thing, then they have to be equal to each other. And this one maybe seems a little more confusing, but if you really think about it, it does make sense. If I have two things both equal to the same thing, the only way that can happen is if those two things were the same thing in the first place. So let's say in one question you have x equals 5, and then you solve for y, and y also equals 5. Well, x and y are the same thing. They both equal 5. They have to be the same thing. And that's the transitive property. If two things are both equal to the same thing, then they have to also be equal to each other. So we have three properties of equality: reflexive, symmetric, and transitive. And our next group is called the identities, or the identity properties. Now, an identity is a math operation. Now remember, operations mean like add, subtract, multiply. It's when you do something to a number. And an identity is a special operation that doesn't change the number that you're doing it to. So basically, if I start with a number, like pick any number you want, like 2. An identity is something I can do where the answer stays 2. So think for a second, what do you think the identity for addition is? And you can pause the video if you want to stop and think about it for a second. But basically, it's 0. Adding 0 to a number doesn't change it, and that's what we mean by identity. So I said if I start with a 10 and I do plus 0, the answer is still 10. That's why plus 0 is called the addition identity. So now, what's the one for multiplying? What can I multiply by and not change a number? And then the answer for that one is 1. Multiplying by 1 does not change. If I start with a 7, 7 times 1 is still 7. So that's what we mean by an identity. An identity is something that you can do to a number that doesn't change it. And the two easiest ones to work with are adding 0 or multiplying by 1. Now our third set of properties is called inverses. And when you're talking about an inverse in math, the best way to think about it is an inverse either cancels out something you've done or basically undoes. It does the opposite of something that you've done. So an inverse property is something that will cancel out or undo something that you've just done. So if you think about adding, like if you think about, let's say you're solving equations and you want to cancel out addition. To do that, you use opposites. Use opposite signs, like addition and subtraction, or positive and negative numbers. So the inverse property for adding is using the positive and negative version of the same number. And I gave you an example. I said 10 plus negative 10 cancels each other out and leaves nothing, leaves a 0. And that's an inverse. So basically the positive and negative version of the same number cancel out when you add them, and that's what we mean by inverses. And then if you think about multiplying, it's a little trickier, but the way you cancel using multiplying is actually with reciprocals. You may have thought to yourself divide. Multiplying and dividing cancel, and that's kind of true. But if we want to think about multiplying, and let's say we're not really counting dividing, then multiplying by reciprocals is like dividing. So I said if you have a 7 and you multiply it by 1 over 7, or 1/7, the answer is 1. The 7's cancel. Or if you have an actual fraction like 2 over 5 and you flip it and multiply by 5 over 2, that also cancels and the answer is 1. So those are your inverse properties for adding and multiplying. Adding is same number, 1 positive, 1 negative. That'll give you a 0. And multiplying is multiplying by a reciprocal, which gives you a 1. So when we say cancel out, depends on what you're doing. Canceling when you're adding gives you 0. Canceling when you're multiplying gives you 1. It's a little bit different. Now speaking of 0, multiplying has a special property for a 0 where everything that you multiply by 0 always equals 0. So any number times 0 always equals 0, no matter what. And I gave you some examples. The first one is super easy. 10 times 0 is 0. Anything times 0 is 0. And then for the middle one, I said, even if it's a really big, maybe negative number. So I said negative 21,387 times 0, still 0. Now the third one is the trickiest one of all because I gave you an expression. It has x's and y's in it. I said 17x to the 5th y cubed times 0. Now some people might have said, okay, well now it's getting harder. Maybe it doesn't equal 0 anymore, but it does. Even if you have variables in there. 17x to the 5th y to the 3rd times 0 still equals 0 because anything times 0 equals 0. That's the 0 property. So then the last group of properties is called the ordering properties because it has to do with kind of like order of operations. You know, do I have to do things in a certain order? So we have first the commutative property. It says if you are adding or multiplying, now remember this is adding and multiplying only. This doesn't work for dividing and it doesn't work for subtracting. But for adding or multiplying, it says the order doesn't really matter. I could say 2 times 3, I could say 3 times 2. It doesn't matter, they both equal 6. Same thing with adding. I could say 2 plus 3 or 3 plus 2, it doesn't matter, the answer is 5. So as long as you're talking about adding or multiplying, you can flip the numbers and it doesn't really matter. Now subtracting and dividing does. Okay, the next one, and people get these two confused all the time. The associative property, it's very similar to commutative property, but it involves more numbers, bigger groups of numbers. So if I had 3 plus 8 plus 2, because it's all addition, remember this doesn't work for subtraction, but if you have all addition, it actually doesn't matter what order you add them. I can do the 3 plus 8 2, I could do the 8 plus 2, I did 3 plus 8 first, I could do the 8 plus 2 first, I could actually take the first one and the last one, I could do the 3 plus 2 first if I wanted. So if for adding or multiplying, if you have a whole bunch of it, you can do it in any order. And that, also, important note, I mentioned this earlier, but to type it into the slide, not for division or subtraction. Division or subtraction, that's order of operations. You kind of have to go from left to right on that one. Okay, that leads us into our first example. I said, let's evaluate the expression and name the property that you use for each step. So I'm doing 7 plus 8 plus 23 plus 12. And let's say I look at this question. Let's say I want to do it without a calculator. I want to do it all just by, like, right here in my head, basically. Now, if I just start going in order, if I go, okay, 7 plus 8, that's 15, and 15 plus 23, it's starting to get a little tricky. So what I'm going to do is I'm going to say, well, this is all adding. And the associative property says I can add in any order I want. So let's see if I can group some of these up to make it easier on me. Like right here, for example, I say, well, this 7 and this 23, if I put those together, that's 30. You know, we like getting nice even numbers, like multiples of 10, 10, 20, 30, 40, things like that. And then I notice the same thing with the other two numbers. The 8 and the 12, those would add up to 20. So what I'm going to do, I'm going to take a second and rewrite this question. Because of the associative property, I can put them in any order I want. So I'm going to do the 7 plus 23 first. And I'm going to do the 8 plus 12 second. Now remember, I said up here, name the property that you use. The property that I used was associative. I said I'm adding up a whole bunch of numbers. I can do it in any order I want. I'm going to move them around. Now, the rest of it, I'm just going to finish the question. I said the reason I did this, 7 plus 23 is 30. 8 plus 12 is 20. 30 plus 20 is 50. So see how by regrouping numbers, this is called mental math. You know, if you just start adding 7 plus 8 plus 23 plus 12, you can't really do that in your head, or it would be hard anyways. But if you get used to mentally moving, grouping numbers around and saying, okay, well, these two together just give me 30. These two together give me 20, so it adds up to 50. It becomes much easier. Now, here's the other type of question you guys are going to see in the homework today. It says, find the value of x, tell the property that you use. Now, we're not solving for x. We're not quite there yet. We will do a lot of solving for x this year. But right now, we want to use properties and see if we can figure out what x is. So x is my variable. That's some number. I don't know what it is. I'm trying to figure it out what this is right here. I'm multiplying it by 1/12. And the answer is 1. Now, if I'm multiplying by anything, really, and the answer is 1, what I'm using is the inverse property. Because remember, the inverse property is where you multiply and cancel. And for canceling when you're multiplying, it means the answer is 1. So what I need to do, working backwards, is x has to be the inverse of 1/12. Now for multiplying, when we say inverse, what we mean is reciprocal. So in words, this question is asking you what number times 1/12 equals 1? And the answer is 12. 12 times 1/12 would cancel out and equal 1. And since I also asked you to use the property that you used, I already wrote it here, but the property we used is the inverse property. So that's basically what you guys are going to be doing in today's assignment. You're going to be using these properties to answer questions, and for probably today only, I'm actually asking you to name the property. I told you normally, like, don't worry about memorizing the names. You can use your notes for this, but what you really want to focus on is understanding these concepts of the properties.